Picture an old CCTV system. The analog cameras are tired. The DVR is one power cycle away from retirement. The owner wants to move to IP surveillance. The new cameras and the new NVRs are easy purchases. The hard part is the cable is already in the walls, running through elevator shafts, across parking lots, sitting in the conduits nobody wants to open. Pulling new Ethernet to every camera means lift rentals, ceiling work, after-hour access, sometimes transient. Cable has a weight on the budget. Labor has even more. There's another problem on top of that. Standard Ethernet over copper tops out at roughly 100 meters. A lot of these existing runs to parking lot pole, the perimeter fence, the camera at the back of the warehouse already past that limit. So even if you were willing to pull new cable, you'd still hit the wall on the both IP data and PoE power. That's a problem. The original Linovision UltraReach EOC was built to solve. The first generation launched about 8 years ago and has been one of our best-selling products in surveillance retrofits ever since. UltraReach EOC carries IP data and PoE power over existing Coax, RJ59, RJ6, RJ11, and even UTP and a twisted pair cable for past 100-meter Ethernet limit. The camera and the NVR get upgraded. The cable in the wall keeps its job. And today, we're looking at EOC2. Same core idea, same UltraReach foundation, stronger engineering for long-term surveillance deployments this system actually live in. And let's get into it. EOC2 isn't a replacement in a functional sense. Both versions meet the same core requirement, IP data and PoE power over coax that's already there. What the upgraded edition EOC2 adds is on the engineering side, structural and cooling refinements aimed at the kind of installs these things actually live in. The installation experience is the one thing EOC1 got right, and EOC2 keeps it. Receiver on the network side. Plug into your PoE switch or your PoE injector. And transmitter on the device side. Connect to your IP camera or whatever PoE device you're feeding. Existing coax is in between. No configuration, no framework setup, no pairing app. You connect it, you power it. It links. Let's step back from EOC2 specifically for a minute, because the next thing I want to talk about isn't the EOC2 feature. It's about the EOC platform itself works, and how to evaluate whether your project fits it. The EOC product line, both EOC1 and EOC2, is built around two core compatibilities. The first is UltraReach PoE. The second is multimedia compatibility. These have been part of the platform from the start. The first compatibility is UltraReach PoE. Long-distance IP data and PoE power deliver over a single existing cable run. Standard Ethernet and standard PoE over copper top up roughly 100 meters, about 330 feet. The trouble is, the cameras you actually need to upgrade aren't all sitting within 100 meters of the network room. The parking lot pole is 250 meters out. The premier fence camera is past 400. The camera at the back of the long warehouse is well beyond that limit. The Ethernet standard says 100 meters. The building often says otherwise. UltraReach PoE is what extends the path past that limit into distance real surveillance projects actually need. The second capability is a multimedia compatibility. The EOC platform doesn't lock you into one cable type. It works over coaxial cable, RJ59, RJ6, RJ11. It also works over UTP and a twisted pair. That matters because all the surveillance sites are really homogeneous. You will find RJ59 from the original CCTV installs in one zone, RJ6 or RJ11 in another. twisted pair from abandoned intercom run somewhere else. UTP that was pulled years ago from a system that's no longer there. Almost no real retrofit site is a perfect cable type from the end to end. With multimedia compatibility, the existing cable, whatever it happens to be, get a second life as IP camera pathway, terminated into the EOC pair, delivering a standard PoE to the camera at the far end. Together, these two compatibilities are what makes the EOC platform Retrofit 2, rather than just a longer distance Ethernet alternative. UltraReach PoE addresses a distance optical. Multimedia compatibility addresses the existing cable optical. Most analog to IP retrofit run into one or both of these opticals, and the platform was designed to work inside both of them. We just said UltraReach extends the transmission path, but doesn't suspend the law of the path. Now, let's get into what those laws actually look like. This is a section where the project goes from feasible in principle to feasible at this distance. With this cable, for this camera, the number matter. EOC2 work as a pair. The EOC2 transmitter and the EOC-R2 receiver are designed to operate together. And over existing coax, they carry both IP data and PoE power on the same link. Depending on the distance and the cable condition, that link can extend up to 1,000 meters, about 3,280 feet. The real advantage on long camera runs, elevator upgrades, parking lots, property edges, and older buildings, where pulling fresh Ethernet means opening walls, ceilings, conduit, or whole sections of the finished space. Reuse the existing infrastructure. A lot of that cost and downtime simply goes away. But the headline distance is only part of the design. To use it correctly, you need to understand how bandwidth, load capacity, cable type, cable condition, and power budget all change across the run. A quick note on how the link actually works, because it matters for sizing. The receiver sits on the upstream side and accepts PoE input from your existing PoE source. And for stable operation across long runs, a 30-watt PoE plus source is recommended. Power and Ethernet data coming there get regenerated and passed down to the coax to transmitter at the camera end. The transmitter acts as a standard IEEE 2.3 AF80 compliant PSE, so from the camera's point of view, it's just a plug into the normal PoE port, standard compliant on both ends, with the coax doing the long haul in between. Well, this table really gives you a practical sizing guide for long-distance PoE deployment over existing coax. With RJ59 cable and 48 volts PoE input, the EOC link can maintain 100 megabits per second bandwidth up to 400 meters. And this is important because many surveillance upgrades don't fail because of bandwidth first. They fail because of power budget at the far end was not properly matched to the camera. At 100 meters, the system provides 100 megabits per second bandwidth and up to 21 watts load capacity, giving most fixed IP cameras plenty of the operating margin. At 400 meters, the link still maintains 100 megabits per second, with up to 9 watts available at the camera end. For low-power fixed cameras, this can still be a very practical long-distance retrofit solution, especially in places like parking lots, perimeter lines, warehouses, and older buildings where pulling new Ethernet would be expensive or disruptive. At 1,000 meters, the system still supports a long-reach IP camera path with 10 megabits per second bandwidth and a 4-watt load capacity. And that makes it suitable for carefully selected low-power fixed camera applications where distance is the main challenge, and the endpoint load is modest. So the value of this table is not showing the maximum distance, it shows how to match the camera to the run. If the project uses the right camera at the right distance, EOC gives you the practical way to reuse existing coax, extending beyond the standard Ethernet limit, and avoid unnecessary wiring. So, the key is the proper sizing, with distance, bandwidth, and the camera load are matched correctly. The existing cable can keep doing useful work in a modern IP surveillance system. Cable choice and cable condition matters just as much as the distance. The BNC port supports RJ59, RJ6, and RJ11, as well as UTP and twisted pair, but they don't all behave identically. Existing splice, connector quality, aged jackets, water damage, and a real past cable take through the building, all of that affects what you will see at the far end. So before you commit to a long run, take a real look of what's already in the wall. Don't assume that spec sheet number applies on every job. On the device side, two things confirm upfront: the endpoint network requirement and the power requirement. How much bandwidth does the camera actually need at the resolution and frame rate you are running? And how much power does it really draw? Especially anything with IR illuminators, PTZ motors, heaters, wipers, and supplemental light. Pulling the actual draw from the camera spec sheet, not the label rating, and use the worst case number, cold start, IR fully on, PTZ moving, and check it against 100 meter, 300 meter, and 1000 meter figures. If the math doesn't work, the link will look fine on day one, and then start rebooting cameras at 3 in the morning when the IR cuts in. That's a failure mode this table is meant to flag. So here's a balanced way to think about it. EOC2 gives you a real way to reuse existing coax for long-distance networking and standard compliant PoE delivery. Maximum distance is valuable. Correct sizing is what makes it reliable. There are really only 3 upgrades on EOC2 worth talking about. A refined integrated design, it added the bottom aluminum heat sink, and it improved the PoE and the data stability, which comes directly out of the first two. Started with a refined integrated design. This isn't about the looks, it's about enclosure. The board mounting, the connector layout, and the heat path all working together as a cleaner physical platform. Take one apart, you can feel it. Everything sits where it should, and the thermal interface between the board and the body is more deliberate. And the whole thing just hang together better as a single unit. That sets up the second upgrade, and this is the one that does the real work. They added the bottom aluminum heat sink. Aluminum on the bottom gives the heat somewhere to actually go. A direct pass off the active components on into much larger conductive surface. Less thermal stress on the electronics. More headroom when the unit is running hard for long stretches. And that's where the third point comes from. Improved PoE and the data stability is a direct outcome of the tighter physical design and heat sink underneath. When the electronics aren't running hot, PoE delivery stays steady and the data link stays clean. Bench testing on the same RJ5 net cable at the same input voltage puts EOC2 roughly 50% further on 100 megabits per second usable distance compared to EOC1. The total reach hasn't changed. What changed is a runway at a full 100 megabits per second. A high bandwidth zoom gets 50% longer, which directly benefits the camera that actually need that bandwidth. 4K extremes, high frame rates, bandwidth-hungry IP installs, same maximum reach, more useful room inside it. One thing to be very clear on, because I have seen this go wrong on multi-camera installs. This is a dedicated point-to-point product. One transmitter, one receiver, one cable run between them. It's not a multi-job system. Don't try to bridge it. Don't try to daisy chain it through a tap. If you've got 6 cameras, you've got 6 pairs. Quick compatibility note before you spec this in. EOC2 is on platform. It's not interoperated with first generation EOC1. It does not work with EOC Switch. Treat it as a clean sheet deployment. Match the T2 and R2 pair end-to-end. If your project is built around a EOC Switch or existing EOC1 hardware, stay on the EOC1. If you are starting afresh, design around the EOC2 from the day one.